Нет, спасибо. Я хорошо себя чувствую, Лиз. Возьми, Лиз.
Okay, hi everybody. We're gonna get started, and this will be recorded for anybody who's not able to attend or if you want to watch it again. So yeah, we're excited to go over your final review session.
Yeah, so let's get started. Also, if at any point, this is the first time that I think Hadley or I are recording, so if at any point you stop seeing the recording button, let us know because that means that we're not recording it. So Annie will also be here and she will be answering the chat box. So, oh, can I not? Okay, there we go. So to start off with like the format and the logistics of the exam, so the exam will be very similar to the midterm. There will be 10 questions on definitions and 40 multiple choice. If you want to find out which 10 words, the list is on Courseworks. It will be available from 6 a.m. to 6 p.m. on Tuesday, May 12th. And you will get 100 minutes to complete the exam once you open it. So are there any questions with regards to format or logistics? Let's see, chat. Depose the terms to learn for final, like he did for the midterm. Yeah, he did. It's on Courseworks. Oh, okay. Any other questions? Awesome. Okay, let's go on to the next one. So quickly, this is what we're gonna be going over right now. Just for you to get like an overview of what we're about to cover. So we're gonna go over a bit of sort of before midterm material, and then a couple of midterm questions that were pretty popular and that a lot of people got wrong. And then we're gonna go on to cover things that are more relevant for this half of the semester. So.
Okay, so we can start off by going over the stuff that we covered for the midterm. Do you mind going forward, please?
Yes, sorry.
No worries, thank you. Sorry, I've not seen this GIF yet, and this is really funny. So I'm sure you all are very familiar with the primitive dative types at this point. So I don't think we really need to spend too much time going over those unless anybody has specific questions, but we've been using these all semester. And then for algorithms, we talked about sorting and search algorithms. So some ones to be familiar with are selection sort, insertion sort, and then we'll get back to the other ones in a second. But yeah.
Oh wait, sorry, one quick note.
Yeah, what's up?
So for the primitive data types, I just wanted to mention Professor Cannon really loves asking questions about like how like storage size in relation to like the data type that's involved. So you should make sure that you at least memorize this chart and know the sizes of like what is a byte? How big is an inch? Because you might have noticed that those questions came up during the midterm, and there's a very high chance that he will ask you the same things on the final.
Yeah, definitely. These are easy points that everybody should get, so make sure you remember this.
Absolutely.
So,
I can talk about sorting
yeah.
algorithms.
Go for it, Hadley.
Okay, so these are the algorithms that we've covered a lot. Do you mind going forward, please?
Yes.
So this is selection sort, as I'm sure you all recall. There's a visualizer linked here that you can use when you're reviewing this on your own. But you just go through the list and find the minimum value and then swap it, right?
Yeah.
I always need to check myself with these.
Yeah. And then next we have like insertion sort. So sort of like the idea of insertion sort is basically as you go, you're trying to see where the element you are at fits. So for example, here we have the array at the beginning, so 4, 3, 2, 10, 12, 1, 5, 6. And then when you start at 4, you check, okay, is 4 greater than 3? If it is, then you move 3 forward. And then now you have 3, 4, 2. So then now you compare 4 to 2. Should 2 go forward? And it is. So then you compare 2 to 4. So you push it forward. And then you compare 2 to 3. So then you push that forward. And it gives you 2, 3, 4, 10. And that's sort of like the same pattern. Again, we added a visualizer on the slides. So we will also be posting the slides. And we added a visualizer because it's an easy way to make sure you're able to see it. So the midterm had a lot of questions having to do with algorithms. I think the final is less likely to have that, but definitely be ready for a question asking you to do selection sort or insertion sort. Oh, also, this says selection sort. So this should be sorting algorithms insertion sort. This one's not selection sort, this is insertion sort. We will fix that before we post the slides. Do you want to do the next one, Hadley?
Sure. So we talked about two different main search algorithms, binary and linear. And binary, when I took the class, and I'm sure he still describes it this way, Cannon talked about like a phone book. And so it's basically you take the entire phone book and open it up in the middle and then decide, oh, is the thing I'm looking for in the left half or in the right half? And depending on which half it is, then you just ignore say it's in the right half, you ignore the left half, and then you split the right half into two and do the same thing over and over again. So you can see in this illustration, they're dividing it into two sections repeatedly. And so that way you can get to the thing that you're looking for ultimately. And linear search is just the classic of going through the entire list of things one by one. So here they're looking for 20 and they just go through each index and check to see if it's 20. So binary is more efficient than linear. You can see binary is O log n and linear is just O of n.
So we're gonna go on to the next one. So another thing that you guys should also have in mind, and I don't know if you remember, but von Neumann architecture. So just sort of knowing what these four main parts do, and also just having them ready for definition. So I believe these are in the definition list as well. So make sure you remember these. Are there any questions so far? Oops. Questions?
And feel free to ask questions in the chat as they come up and we'll come answer them.
Awesome. So there seems to be no questions, so we're going to continue.
So we talked about different representations of numbers. I said binary representations at the top. I guess that's not maybe the most accurate way to describe this slide, but decimal, binary, and hexadecimal are three different ways to represent numbers with different bases. So decimal, we're all super familiar with. That's how we normally talk about numbers. And binary is base 2, so it's only ones or zeros. And we talked about the 2's complement, which is a way of noting binary. And then hexadecimals is base 16. So you go through 1 through, or 0 through 9, I believe, and then you go through A through F. So these 3 numbers that I put up, like 939, this long binary number that's a bunch of ones and zeros, and then 3AB, all represent the same number but in different base notations. And I think on the midterm there were questions about converting between these, and it would be good to still be familiar with that on the final, even though it's a little bit in the past, just to make sure, especially with binary, that you recognize how to convert between binary and decimal.
Awesome. So next up, we have classes. So this was sort of in between the midterm and a little bit after. So if you guys remember, when we create a class, this is an example that Hadley added. So we have public class die, which its instance variables are int n and int size. And then you have public die int shape, n is equal to shape, and then you have a role, right? And inside, oh, awesome, there we go. So these are the instance variables. And then here, if you notice, we have 2 different constructors, right? So one constructor for when there is an input, and then one constructor with no input. So let's see, oh, there we go. So if you guys notice here, we also have the roll method, which essentially just rolls it, and then it gets size, which just returns the side. Are there any questions with this class? Do you want to add anything to it, Hadley?
No, that sounds good. I think you talked about overloading the constructor, but that is something tricky just to make sure you understand. If anybody doesn't understand that, feel free to ask a question, but I think Ileana did a great job of describing it.
Any questions? Let's see. Okay, there seems to be no questions. Really feel free. We might end this early so we can.
Wait, I actually have a question. Sorry.
Yeah. What's up, Sarah?
What's the purpose of overloading a constructor?
So essentially, sometimes you want to provide a parameter to the constructor, and sometimes you don't. So for example, here when we have public die and shape, so for here we're telling it what shape we want it to be, right? And here we just have like a basic die that is just 6. So for example, if I wanted a die that was like say 10, I can have that. And if we didn't have 2 constructors, then either I could just pass it in or have a default. So sort of like a way to have a default and then to have one where I can input whatever I want. So another way that we've also used it is to sort of handle 2 different types of data, right? So if you guys recall, with the zip code to barcode and then the barcode to zip code, if your input was a string, it went through the constructor that dealt with that, right? So having a barcode and then moving it to zip code. And then if you inputted an integer, it went through the constructor that dealt with going from zip code to barcode.
Okay, thank you.
Does that make sense?
Yeah.
Any other questions about that? It's a really good question. Alrighty, so small pop quiz. These questions were actually from the midterm and were some that a lot of people got wrong. So let's see if you guys are awake. What method gets score belongs to which class? I guess you had options before, so it was a lot easier. But anybody? The method get score belongs to which class? So basically, what class does get score belong to?
Player?
Exactly. How do you know, Sarah?
Because the variables P1 and P2 are in that.
Yes, exactly. So, can you guys see my pointer? Or just my slides?
We can see your pointer.
Yeah, we can see it.
Oh, awesome, awesome. Okay. So if you guys notice here, we have p1.getScore. P1 is an instance of the player class. And so we know that getScore has to belong to the player class. So, I guess this is player. Okay, so, this class has two constructors. This is an example of, kind of gave it away already, but
I have a question.
yeah, what's up, Will?
In class game, so we're essentially, when we say private player P1 and P2, we're like the player class, right? To like access it.
Exactly.
Or-
Yeah, exactly. So you're building an instance of the player class, right? So if you notice, like you have your instance variable, like private player P1, and then inside your constructor, you have new player 1. So from there, you're basically constructing that by feeding in the 1. I guess this is like very similar to, we did this in NIM, right? So sort of like building this new player object at P1 is equal to new player 1, and then we have another P2. Does that make sense, Arlo?
Yeah, thank you.
Any other questions with this? Really, any questions about this? This is like the meat and potatoes of a lot of what we're going to be doing.
Wait, I have another question.
What's up?
A player of 1 and player of 0. Can you remind?
Oh, what does that do?
Yeah, like 1 and 0. Is that like?
So just from like this example, we don't really know, right, what 1 and 0 are. But if we look back on our homeworks, for example, we used this to identify 1, I think, was a player and 0 was the computer. And also, correct me if I'm wrong, Hadley or Ani, but I believe it was like, which one are you? So you could either make, or was it the turn?
I think it's
The turn. How did they use it?
It was whether the computer or the human played first, right? I think.
Yeah.
Or it might have, there were two things you could specify. There was like a mode, a difficulty mode, and then there was also like who goes first. I think the difficulty mode might have been you get to choose the difficulty, and then whoever goes first was randomly generated. So, but yeah, like Ileana was saying, in this case, you don't really know what the constructor will be doing because we don't know what the player class looks like in this example. But yeah, like you can think back to examples of NIM where we kind of passed in something as a parameter when we called the constructor of the player class. Yeah, you don't have to worry about it for this example though.
that sounds great.
Also, another question. So right within the play method, where in the while condition where it says p1 dot get score, what is the implicit parameter? Can someone tell me can someone unmute themselves or write in the chat what the implicit parameter is?
P1.
So recall that the implicit parameter is the object on which the method is invoked. So in this case, as a follow-up question, is getScore a static method or an instance method? Is it a static method? It's not a static method, it's an instance method, right? And how do we know that? Because it's being invoked on P1. So Ileana and Hadley will talk about this more in another slide, but static methods are methods that are not invoked on an implicit parameter. What is an example of a static method that we've seen before in our previous projects?
With math.
Math.square root, math.random. There's also integer.parseInt, which is another example of a static method. How do we know that they're static methods? Because when you call these methods, you call them by specifying the class to which the method belongs to, using an uppercase letter. So for instance, when you do math.square root, you would do math with a capital M dot square root, and then in between the parentheses of the square root, you would specify the number that a numerical value that you want to get the square root of. Static methods are, another question that might come up is, Professor Cannon might ask, which of these is a static method? And you would kind of try to first identify the class name that the method belongs to. Usually that's denoted with an uppercase letter. And then that should give you a big hint as to which option is a static method versus instance methods, which are methods that are invoked on an object. And in this case, getScore here is an instance method. So I see that there are some questions. So Megan asks, why is it an example of overloading? What is it referring to? Are you referring to the game constructor? So the game constructor here is being overloaded because we have two constructors that have the same name because they're both named as game, right? Game is the name of the class. And we know that when we write constructors, we have to write constructors so that they match the name of the class. So it makes sense that we have public game, and then we have another constructor that's also called public game. However, where they differ is their parameters, which is what comes between the parentheses. In the first game constructor, takes in no parameters. There's nothing in between the parentheses. That is the default game constructor that gets called when you create a new game object, when you create a new instance of the game class. In the second game constructor, the second one takes in two ints, the int first and int second. So because you have two constructors that have the same signature, aka the same name, but different parameter types, that's called overloading. And overloading is a concept, it's a term that can be used, that can be applied for both constructors and methods. We can say like method overloading, we can say like overloading a constructor as like, just as a terminology note. Okay, so Megan asks, is anything above one constructor in a class considered overloading? What do you mean by anything above one constructor in a class? Do you mean everything that comes before the game constructor here? I'm not sure if I understand the question.
I think it's just that if you have more than one constructor, are you overloading?
Oh, I see. That's interesting. Can you ever have multiple constructors that don't have the same? Yeah, I think it has to be overloading. Yeah, because by default, the constructor has to have the same name as the class you're in.
Mm-hmm.
So, yeah, cool. I hope that clarifies things.
So I think this one is there.
Oh, sorry.
Are there any other questions? Thank you so much, Annie. You explained it so well.
Thanks, Zoya. No problem.
You can have 10 constructors, right?
You could. I believe there's no limit to it. I guess you would have to get really creative about how to have 10 constructors, but I think you could, right? There's no limit on.
I don't think there's a limit. I think it would just get really confusing.
Yeah, it would just get messy.
Oh, actually, something interesting is if you look at the Java documentation for Scanner, the Scanner class, you'll notice that there's actually a lot of different there's like actually 10 different constructors
Oh my
for Scanner. Scanner can take in a file, or it can take a file and a string, or it can also take in other like variable types of other classes that we haven't really seen before. There's a class called input stream. There's a class called path. There's a class called readable. Scanner can take in all these different types of variables. So yes, you can have like 10 different constructors, and in fact, some Java documented classes already do have that many constructors, such as the Scanner class.
And I think it's crazy how you knew this.
I literally just skimmed through it. Like when I was looking up scanner, I was like, why are there so many ways to call scanner? But very
That's
interesting.
great. That's awesome. Alrighty, so I think the next question is which of the following are explicit parameters of the play method in the game class? Anyone?
Aren't there not any?
Yes. True question. There are none. So, if you notice here, right, we have, it's asking which of the following are explicit parameters of the play method in the game class. So, play in here. So Sarah, why is it none?
Because there's nothing in the parentheses, right?
Mm-hmm.
Exactly. So if we look at play in here, play doesn't take in any explicit parameters, right? And we know that something is an explicit parameter because it's in between the parentheses. And something that Annie also talked about was implicit parameters, right? So when something is called on an instance, so when you have something dot play, that would be considered an implicit parameter. So we know that there are no explicit parameters because this play method doesn't take in anything through here. Are there any other questions with that? Hadley, do you have anything to add, or Annie?
I think that's good.
Awesome. So are there any questions in the chat? Amazing. So we're going to go on to the next slide. Military role.
Finals are done.
This is all Hadley's mastermind,
This is amazing, Hadley.
except for the Kermit one. I'm very proud of that one.
Yeah, you did the Kermit. That was great. That surprised me in the best way.
All right. So do you want to get started, Hadley?
Yeah, so this is just an example of Boolean logic and circuit construction. You all had one problem set that was all about this because you had to make a few different circuits. But the idea is that when you have a, not a formula, but an expression, yes, like this z equals not a plus not b, you can draw out a truth table and then create a Boolean circuit, or you can create a circuit based off of the Boolean logic of this with different and or gates. Have you gone over NOR or NAND or XOR? Maybe you know those two, but all of those you can do simplified. Like if you wanted to have a NOR gate, you could just use an inverter and an OR gate. So you can simplify them and just use the most basic gates, whichever makes the most sense to you. This is just like an example picture I found on the internet because I thought that this would be like an okay explanation of it, but if you all want more of a further description, I can try to find a practice problem. How does everybody feel about Boolean logic and circuit construction?
I think one thing that you might find helpful for studying this is, I believe it was PSET 3, where you had to construct like a 1-bit subtraction circuit and also like the standard circuit. For this class, you just have to worry about and, or, and not gates. And another thing that might pop up on the final is Professor Cannon might give you a certain number of gates and ask you how many transistors there are. That was definitely a question that came up during the practice midterm and like the actual midterm. So let's just review that really quick. Can anyone tell me how many transistors there are for an AND gate? You can unmute yourselves or you can speak in the chat.
3.
Right, there's 3. What about an OR gate?
3.
And then how about not?
1.
Yeah. So just make sure to keep all those numbers in mind. If you're curious about why they have those numbers, that was something we tried to go over during a previous midterm review session, but you don't have to worry about like the nitty-gritty implementation details. That's more of a fundies question. Fundies is a course that you'll take that kind of goes a lot in depth about like circuitry and all this hardware stuff, and you'll kind of analyze these concepts more in depth later on if you continue in the CS track course. But for now, just keep that in mind because Professor Cannon likes to ask those types of questions.
Can you review what those lines about A and B are, and then also dot and versus plus? Which one is?
Yeah. So the dot means concatenation. So that's like A and B. And then the line that's above the expression means the complement. So for instance, if I looked at like on the way right in the chart, right above the chart, where it says Z equals, and then A with a bar on top plus B with a bar on top, that is saying take the value of not A and OR it with not B. The plus sign represents OR. So in here, if our initial, okay, so I have a question for you guys. If we set A to be 0 and B to be 0, oh, well, I guess the chart kind of gives it to you. But yeah, what the chart is saying is basically if you assign A to the value 0 and B to the value 0, then not A becomes 1 and not B becomes 1. And we know that for an OR condition, for an OR expression, a Boolean expression with OR to be true, either side of the expression, either the left-hand side or the right-hand side of the OR sign has to be true. So we know that either not A or not B has to be true. Either one of these has to have the value 1. And we know that that's the case here because A and B were set to 0. So not A is 1, not B is 1. Therefore, 1 ORed with 1 is 1. So Z, the value of Z is going to be 1. But then let's look at the second row of the chart. If we set A to be 0, then not A becomes 1. If we set B to be 1, then not B becomes 0. But we still have that Z is set to 1 because not A is 1. And for an OR condition to be true, for an OR expression to be true, we only need one side to have the value 1. And in this case, that is not A. Not A is 1. So therefore, Z is 1. So Megan asked, do NAND and NOR have 2 transistors? That I don't recall. Hadley and Ileana, if you happen to know, feel free to jump in, but I don't think, I think that's beyond the scope of what you have to know. So I would recommend going back to the Schneider and Gersting textbook to if you're curious to know how many transistors there are with each of these gates. I personally don't know it off the top of my head, but if anyone else does, feel free to jump in.
I think it might be 4 because it's an inverter plus an AND or OR gate. No? I'm looking it up right now. I think it is outside of the class.
That would make sense, yeah.
Yeah, I think you definitely don't need to know it, but it's definitely good to know. I also think it might be 4. But we can definitely get back to you with a solid answer.
Does anyone else have other questions about Boolean logic, circuits?
Oh, it looks like it does have 2.
Oh,
Interesting.
AND and NOR do have 2.
I wonder why.
I am just looking at a picture of them. It doesn't have an explanation. Okay, but I
Still
wouldn't worry
try
about
for
that
now.
for the final.
Yeah.
Good question, though.
Hopefully we'll learn in Fundies.
are there any other questions about circuits or Boolean logic?
Are B and D good representations? Wait. Good representations meaning, what do you mean by good representation?
The note is not the same as the note in A and C.
Oh, I see. So, if you notice here, So you're basically inputting A, right? And then you're inputting B. And then you're getting the and of that and then nodding it. Versus in the or case, you are feeding in A, getting not A, and then getting not B, and then feeding that into an or. The reason why those two are different is because when you are going to and something, you're basically going, so it basically takes them both into consideration, right? So if A is false and B is true, the output is going to be false. So we can just not it at the end. I guess we could also do it at the beginning, right?
I think it has to do more with like precedence. So like in this case, you would want to make sure you concatenate A and B first, and then you take the complement of that versus taking the complement and then anding. Because those two things are not the same thing. Like one thing you want to keep in mind is like order. So in this expression here, you want to be anding A and B first, and then you take you take the complement of that, which is why the gate is structured the way it is. This expression is equivalent to taking the complement of A and taking the complement of B individually, and then oring those. That has to do more with like, I think it might be like De Morgan's law or something. There's like different logic laws that are involved that you don't really have to know for this class, but just be aware that taking the complement of A and B is not the same thing as taking the complement of A and taking the complement of B. They're totally different. So the not, oh, I see. So Chris, you might be a little confused about the notation that they're using. So yeah, I'm also not sure why they chose to use the small circle on the right and the triangle on
I see.
but I think the way your textbook does it is the textbook uses the triangle notation. But I guess sometimes if you see like a mini circle, just keep in mind that that can also mean the complement. It's kind of annoying that they weren't very consistent, but maybe this is the standard way to draw out such gates. I'm not too sure, but yeah, they're the same thing.
Yeah, just to clarify what Chris was asking. So for this one, for the not gate on A, you see that you have like a dot and then a triangle. So that is not, but then on B, you just have like the little dot. So those two are just equivalent. I think Professor Cannon would probably use the triangle if you even get a circuit problem. So because all of it is going to be multiple choice, he's not going to make you draw anything. So if there is a question on this, my guess is that it would probably be like pick the circuit that is correct, and or based on the circuit, what is the equation? Would be my guess, right?
Yeah,
Yeah, that sounds right.
that's right.
Are there any other questions with this? Alrighty, I think we're gonna continue. So next up we have arrays and arrays lists. So some things that you guys need to remember is that arrays are fixed in size. So whenever we build an array, we basically give it the size that it is going to be. And because they are fixed in size, this means that, for example, if I want to add an element to my array, I basically have to, there are like different ways I can do it, right? But I essentially have to basically reconstruct my array and make the length bigger and then add all my elements one by one. Whereas if we use array lists are able to change in size. So do you guys remember? I believe this was problem set 4. We had like all the manipulations with array lists. So this is sort of where that comes in handy. I don't know if you have anything to add, Hadley or Annie.
So I think one good example of keeping in mind that arrays are fixed in size, is if we revisit the CD collection class that Professor Cannon demonstrated in class, there was an increased size method. And what that method did was, if you try to add a CD to an array that was already full in capacity, what that increased size method did was it would create a new temp array and it of a larger size, and it would basically copy over every single element from your original array into this new temp array. And then at the very end of the method, we basically set the original array to become the new array that we just created more space for. So if you want to revisit like how array manipulation works in terms of increasing its size, I would recommend that you look back at the CD collection class and take a look at the increased size method and what it does within its for loop. That's also one more thing I wanted to kind of mention. So in this slide, in the fourth line under arrays, it says arrays can contain primitive data types or objects of a class. I just wanted to kind of emphasize that arrays they're like bookshelves, right? They hold object references, and the object references themselves are not actually the objects. The object references are kind of like little men pointing to objects. So for instance, when we declared a new CD array, when we created an array that we're basically creating an array that holds object references of type CD. And those object references at the way beginning, when we didn't populate the array, those object references were pointing to null. Everything was pointing to null. They weren't actually pointing to actual CDs until we populated the array using like a for loop. So that's something to also keep in mind, is the fact that arrays hold object references rather than actual objects.
And then one thing I wanted to add too is that array lists, unlike arrays, cannot hold object references to primitive data types. So if you wanted to create an array list that holds ints, you would do, this is like, I don't know if any of you came to the April 3rd review session, but Gianna and I talked about it then. You would use a capital I integer, which is the corresponding object wrapper class for an int. So I'm gonna actually send in the chat just that written out. So it's the difference of integer versus int. I don't know if everybody can see that, but integer with a capital I is the corresponding object wrapper class for int. So an array list would have to hold integer, not int.
Yep. And your textbook talks a little more about this if you want to learn about this concept more in depth. I believe it's a technique that Java uses called auto boxing. I don't know why they didn't call it auto wrapping to be consistent, but yeah, Java comes with these like handy wrapper classes that kind of take the place of these primitive data types whenever you want to use them in special cases, like what Hadley was saying with array lists.
Yep, exactly.
Alrighty. Are there any questions about this?
I have a follow-up question for you guys. So,
Yes.
well, I don't know if it's a question, it's more like a note, but keep in mind that for arrays, when we try to get the size of the array, we do like our array dot length, but dot length is not a method. It's an instance. It's actually an instance variable, and it's very interesting how we're able to have access to this instance variable of the array. But then when it comes to getting the length of an array list, we use the dot size method that we see in the slide at the bottom right. So one mistake I noticed a lot is that sometimes when students wanted to get the length of the array, they would be calling dot length as if it were a method. So they would be writing dot length and then open parentheses, close parentheses, but that's not how you get the length of the array. Keep in mind that dot length is not a method. It's an instance variable of the array class.
Awesome point, Annie.
It's an instance variable as opposed to a method.
Sorry, what was that question? What was the question?
Can you remind me why dot length is an instance variable as opposed to method?
Yeah. So this is a really subtle detail, but dot length does not. So when we do, like, let's say we had an array called R. When we do R dot length is actually a public instance variable that we have access to. It's not a method, and that's why because we don't see any parentheses after dot length. It's not like it's not a method that's being called on the array. It's the actual instance variable that belongs to that array. Whereas for array lists, we have the dot size method, and we can tell that dot size is a method because there's 2 parentheses at the end. Does that clarify?
I get that. I was just wondering why this differentiation between like the same concept of length.
Yeah, that's very interesting. I personally don't know the reason why on the top of my head, but Hadley and Ileana, do you guys have any insights on why this might be?
I don't know. It for some reason the creators of the array class just decided to implement it this way.
Yeah, it's very strange, but
Yeah, I think it's just sort of they did it, so now we have to deal with it. Are there any other questions about this? Alrighty, so we're gonna go on to the next slide. I think just a final note on arrays and array list. A super important thing is being able to use them. So definitely go over the notes on how to build one for both. Just because I know like in the midterm there was like a lot of string sort of problems and like for loops, and then asking what like a specific chunk of code was printing out or returning based on a specific string input. I think for the second half, a lot of this shifts towards arrays and array lists. So make sure that you are very familiar with this, and make sure you know how to use them. So we're gonna go on. Do you wanna go over this, Hadley or Annie?
Sure. So Dijkstra's algorithm was the algorithm to find the shortest path from one node to every other node. So given a graph, you're going to try to find all the different paths between the starting node and the target and see which one is the shortest, assuming the paths are weighted. So it's also known, it solves the traveling salesman problem, which is like, if I have to go to 10 different cities, what's the fastest way for me to go between the cities? So it takes in the graph and the start and the end, the source node and the target node. And what you find through the course of the algorithm is the path from the source to the target that is shortest. So I'm sure you all recall making these tables. I think you had a few of them on the problem set. And so you can start off at the source node and then keep adding the closest node until the target node is in your list, and then work backwards from the target node and see the node updated. You can see which node updated the last one. And I also believe that there is an extensive review session focused on this and a video posted. I think Annie, actually, you made the video that's posted about this.
yeah, there's a YouTube video online. I think it's a pin post or somewhere on Piazza. So if you just search up Dijkstra's algorithm, it should pop up, and you can see like an actual demonstration of how Dijkstra's works with the table and the graph and the list S. So if you guys want to review that, just go to that link that Hadley just sent in the chat.
Yeah, so that's a great example of how to work through this.
Ready. So next up, actually, are there any questions with regards to Dijkstra? Alrighty, so we're gonna go over file IO. So this is sort of how do we take in input and how do we like read in a file, right? So here we have scanner in, use scanner system in. So when we say keyboard input, this means, for example, when we are taking in something on the command line when we run it. So for example, if I had my file, say print numbers, and I ran like Java, print numbers, let's pretend that I already compiled Java print numbers, which is my file name, and then I had 1, 2, 3, and then that just printed out 1, 2, 3 on different separate lines. What that is doing is that it's using scanner to read from that line. Or actually, no, that's args. That is my bad. So another scanner one would be like when we ask for input. So if you guys have really paid attention, every time you want to ask for input, you are doing like you basically have to build a scanner to be able to take in that input. So this is how we sort of communicate with the user. And then for file input, what we do is that we have to open up a file, take in a scanner, and then we basically can go line by line, and then at the very end, close the file. So I don't know, Hadley, if you have, or Annie, if you have like a better way of explaining it.
I think that was good. I think one thing, if you guys want to review file input and output again, maybe try to revisit Programming Project 5, because that's one of the first times where we actually started working with reading from a file. So for instance, in the first line of under file input in this slide, we say file, my file equals new file, and then parentheses foo.txt. So what this is doing is it's basically creating an instance of the file class. So we have a file object. We know that because we see the keyword new being used. So we know that we're creating a new object. And then within the constructor of the file class, we're passing in a string. And this string is basically the name of the file that we want to be reading from. So here, the name of the file we want to be reading from is foo.txt. But it doesn't have to be foo.txt. For instance, in Programming Project 5, you passed in maybe like a variable that was of type string. And this string variable basically had the value of that string variable was the name of the file that you wanted to be reading from. So you can make this file constructor read in from any file you want. It's very versatile as long as you have a variable that kind of holds the value of whatever file you want to read in from. And then in the next line, when we're doing scanner in equals new scanner my file, we're basically, instead of specifying system.in as the parameter of our scanner constructor, we're just passing in a file object. So before, when we were talking about whether or not we can have like 10 constructors in a class, this is an example of us using the overloaded version of the scanner constructor. So in the first half of the slide, we called a scanner by passing in system.in. And oh, actually, my bad. This isn't an example of overloading because we are passing in a file object in both instances of the constructor. Okay, so one thing that I do want to note is on the left-hand side, when we did scanner parentheses system.in, we're basically telling scanner to read input in from the keyboard. But this is a very strange concept because you can basically think of a keyboard as a file. System.in is kind of like the file object that we see on the right-hand side, file, my file. So in both cases, when we're creating a new scanner object, we're calling the constructor of the scanner class that takes in a file object. And it's a weird concept to kind of think of your keyboard as a file, but that's essentially what we're doing in both of these lines here. So that's something that to like just be aware of. You don't have to know like the super specific details behind these constructor calls, but I just wanted you guys to kind of see how the keyboard can also be read in as a file, which is a little weird, but that's kind of like what's happening here.
Thanks, Annie. Are there any questions about this? Alrighty, so we're going to continue.
I can talk some about static methods. Static methods don't take explicit parameters. And when I was doing some research while creating this, I thought a good way to think about when you should make a static method was if you ask yourself, does it make sense to call this method even if no object has been constructed yet? So for example, when you're making a car class, you might want to call the method convert miles per gallon to kilometers per liter, given miles per gallon. You might want to call that even before you instantiated a car, because that's just a simple conversion. It doesn't really depend on a specific car instance. But if you wanted to call a method like set mileage, that's specific. Like, given you don't want to call it before a car has been constructed. Are there any questions about that? Okay. I can also talk about static variables quickly. They're associated with a class, not objects of that class, and only a single copy of the variable is created and shared with all instances of that class. And so I included, it's really nice for when you want to count how many instances of a class are created, or you want to assign IDs to objects. So you can see in the example below with this class stuff, this static int count starts off at 0, and that's going to count how many stuff objects we create. Because every time you call the stuff constructor, it's adding 1 to the static variable count. And that count is true for any object of the stuff class. So the variable is the same across classes. So even if, say I make 4 items of the stuff class, the first one would have count 1, then the second would have count 2, the 3 would have count 3, etc. The fourth would have count 4. And so after I make the fourth one, I still want to go back to the first item, the first stuff object, and say, oh, what's the count at this point? So when I go back to that first object and ask for the count, it will still tell me 4, because the static variable count is true for all objects of that class. Does that make sense?
Could you give another example of like when you'd use this possibly?
Yeah, so the other one I mentioned was when you're creating IDs for objects. So when you're creating a bunch of objects, you might want to have each one have a specific ID. So for example, I had to do a project this semester where I was creating a website with a list of restaurants, and I had 30 different restaurants in it. And so every time I created a restaurant, I just wanted to give I gave each restaurant a unique ID so that I could tell them apart. And so I added 1 to the count every single time and used that to set the ID. Does that make sense? It would be implemented in the same way. It's just I'm using the same implementation for a different functionality, if that is clear. Like one is just to know how many I've created, and the other is to know, the other is to give an ID to each object.
I think another example that Professor Cannon might ask is like, if you think back to our bank account class, so we know that every bank account has its own set of instance variables, right? It has a name and it has like a balance associated with it. But let's say that I introduced a new static variable to the bank account class. Let's say that I introduced a new static variable called transaction count that gets incremented every time we call it like this new method stuff. So let's say I created 3 instances of the bank account class. Let's say I did bank account A equals new bank account parentheses Hadley, and then I did bank account B equals new bank account parentheses Ileana, and then lastly I did bank account C equals new bank account Annie. So all three of these instances of the bank account class have their own sets of instance variables. We each, Ileana, Hadley, and I, we all have our own unique value for balance and name, because we all have our different balances and different names. However, we all share the same instance of a static variable called transaction count. Transaction count is going to be a variable, a static variable, that keeps track of how many transactions all three of us made in total. So for example, if I called stuff on the bank account B by doing b.stuff, then let's say transaction count was initially set to 0. When I do b.stuff, transaction count becomes 1 for all instances of the bank account class that I created. So for bank account A, for bank account B, and for bank account C, all of those objects that I created have a static variable transaction count set to 1, even though all I did was b.stuff. Now let's say I did c.stuff. Then transaction count gets incremented to become 2. All instances of the bank account class we've created so far, bank account A, bank account B, bank account C, all have transaction counts value set to 2. So this is what we mean when we say a single copy of the variable is created and shared with all instances of the class. No matter what, if the static variable's value changes for one class, then it will also change for other instances of the class that we've created so far. Does that give a good example, a concrete example that clarifies things?
Yeah, thank you.
Okay, awesome. That's a great question. And I can definitely see that being on the midterm, being on the final. So keep that in mind.
What's up, Arlo? Sorry.
So when we have static and final, like final static, that means that we cannot increment variable, right? Or can we still increment it?
So my understanding is that final is a keyword that signifies that the value of the variable should not be changed. I don't know if final is directly related to static, but basically, so yeah, final and static are like kind of like two different concepts, but can be kind of like combined together. So for instance, when we have a static variable that's declared to be final, we're basically saying, hey, I want to make a variable that's shared across all instances of a class, but that variable's value should never change. And the never changing part comes from the keyword final. It doesn't come from the fact that the variable is static. So I just want to distinguish between the keywords static and final. They can be used together, but they're like different concepts, if that makes sense.
Yeah, but we can still make a variable equal to that final static plus 1, and then a different variable like pointing to that final static would change, and that's legal, right?
Well, if you're incrementing, so if you declare it to be final, the value of the variable shouldn't really change, I believe.
So if we do a variable equals final static variable, a different variable plus 1.
Oh, I see. Yeah, and then what was your question about that new variable?
Well, that new variable, it's legal for it to change and be incremented.
Yeah, that new variable can be changed because if that new variable was not declared to be final.
Did that answer your question, Arlo?
Oh yeah, I said.
Oh, sorry, I didn't hear you. Alrighty, are there any other questions about this or anything we've covered so far? Alrighty, so next we're going to go over exceptions. So something important to remember about exceptions is that this basically disrupts the program when it's running, and it sort of requires you to handle these exceptions, and these exceptions can be either caused by an error that you have in your program, which I'm sure we're all familiar with, a sort of like an exception that like you put to handle. So with this, there are two different types of exceptions, checked and unchecked. Checked exceptions happen during compiling. So for example, when we are compiling our files, so when we do Java C, and then say file.java, that is when we are compiling the file at first. So if you get an exception during that time, that is a checked exception. And then we have unchecked exceptions, which happen during runtime. So once we are doing Java and then file, and if you get an exception then, that would be considered an unchecked exception. So under unchecked exceptions, we can basically add try and catch blocks, which allow us to check for a lot of different types of exceptions. So for example, if you have a program that only takes in input string, you can put a try and catch exception to make sure that this is like the input is actually a string. So for a lot of the course, we were assuming nice user input, so sort of the user knew what to input and the user knew what the correct input was. And sort of with this past programming assignment, we sort of switched it up and we're like, okay, let's assume that the user doesn't know what they're doing and that they're just going to try to add a lot of things that might break your code. So under here, I know like the image is a little bit small, just a couple of exceptions that we can throw are, for example, file not found exception and IO exception, which is sort of when you're trying to open the file and you're not able to either find it or not able to open it. We also have array index out of bound exceptions, that I'm sure we've all encountered. This happens when like you're going past what you're supposed to in either like a string, an array, really like a lot of different things. So I think the main thing with exceptions is just being able to use them in code. I think if I like obviously like know this, and if I had to guess like how this could be seen in the exam, my guess would be like in a piece of code and then have an example input and see what exception that throws. So make sure you are familiar with like what is a checked exception, what is an unchecked exception, and also what the different exceptions mean. So I would definitely try to remember like IO exception, file not found, array index out of bound. I don't know, which other ones do you guys think we should remember, Hadley?
Maybe number format exception is another one that we've seen, or illegal argument exception. There's a really handy exception hierarchy diagram in your Big Java textbook. I believe it might be chapter 10 or 11, I can't remember which one, but they're also in one of the recitation slides if you want to go back to that. But you should definitely know that hierarchy and know how to distinguish between what's a checked exception versus a runtime exception or unchecked exception. And also keep in mind that what is the class that we've seen before that can throw an IO exception? You can unmute yourselves or you can type in the chat. When we worked with Programming Project 5, there was a checked exception, which was IO exception that could be thrown by what class? When did we have to worry about exceptions in Programming Project 5?
When the file is not found?
So the file could be not found. And so that was, in that case, there would be an IO exception thrown by the scanner class, right? Because scanner is the class that's trying to read in from a file. So if there's no file, then Scanner will throw an IO exception. So that's something to keep in mind.
Are there any questions with regard to exceptions or?
Is the word exception and error like the same thing?
So they are not the same thing. We don't talk as much about errors in this class, but yeah, that's a really great question. They're different concepts, and we don't have to know about like the specific differences for the sake of this course, but just know that just don't try not to use them interchangeably.
Okay, thank you.
Yeah.
Any other questions about this? Alrighty, so now for our final slide, we're gonna go over inheritance. So inheritance is the idea of how one class can inherit attributes and methods from another class. So sort of if you guys recall, for our last 2 programming assignments, whenever we like built, I believe it was like the card object, we had extends comparable. And so what that means is that you are able to use methods and attributes from the comparables class and use them in like the current class that you are in. And so this is super, super useful because this allows us to essentially reuse code. And the way that like I like to think about it is that these classes inherit attributes from like a parent class. And if you are the child of like your parent, you inherit some of their attributes and some of like their methods, I guess, in this case. So yeah, this is super, super useful because it allows us to save time on code, and there are like some methods that you just don't want to rewrite for every single class, right? It's a lot easier to just inherit them from a class that you've already done.
Yeah, I just want to correct something really quick. Instead of card extends comparable, it was actually card implements comparable. Comparable was an interface, and interfaces are different because they're not comparable was not like a parent class. Just to be clear, one example that you might have seen during lecture that Professor Cannon brought up was checking account versus banking account. So like one example of inheritance would be like in your checking account class, in the header of that class, you would write public class checking account extends bank account, meaning that checking account is a class that basically inherits all methods of the banking account class, and it can override those methods, meaning that the subclass, the child class and subclass are the same thing. The subclass that inherited the methods from the parent class, which is bank account, can provide its own implementation of the methods that it inherited from bank account. This is called method overriding. So, for example, when we created checking account, when we created a new instance of checking account, we know that checking account has to have all the methods that bank account has. It has a deposit method, it has a withdrawal method, it has everything that we've seen so far, but it has extended functionality. And that functionality is whatever you tell a checking account, this is called method overriding, which is different from method overloading. Overriding a method is when you provide a specific implementation of a method in a subclass that's already provided by its superclass. So like one example is, maybe let's use the transaction count example again. Maybe I have maybe like every time I call the deposit method on an instance of the checking account class, I will increment transaction count. I will not only call a deposit that was inherited from the parent class, but I will also increment transaction count, which is this new variable that I introduced. In this new version of the deposit method that I just wrote for my checking account class, that is called overriding a method. So Eleni has a question. When we say superclass, do we mean it in the same way as the parent class? And yes, yeah, superclass and parent class are the same thing. Similarly, subclass and child class are the same thing. So so just keep in mind that the keyword that we use when it comes to inheritance is extends, and the keyword that we use when it comes to using interfaces is implements.
Thank you so much, Annie. Sorry.
Yeah, no worries, no worries. And then I think one more thing I wanted to mention is the keyword super. So for instance, in the checking account class that extends bank account, you would, in the constructor of the checking class, you need to have a call to the constructor of the parent class as the first line of the subclass's constructor. So for example, let's say we wrote a constructor for checking account. You would have to use the keyword super to call the constructor of the parent class as the first thing you do, because you have to initialize the variables of the parent class because you can't access the instance variables of the parent class. The only way that you can do that is by using the keyword super. And yeah, I think that's what I wanted to mention. So, okay, Eleni asked, can we also talk about the differences between throw and throws? Yes, we can. So throw indicates that you are launching an exception. Throw is basically saying, okay, I have an exception and I'm voluntarily choosing not to handle this exception right now. I'm going to throw it and let it be handled in, let's say, a try-catch block. I'm not going to take care of it right now. I'm just going to throw it to let someone else handle that issue for me. Throws, on the other hand, is a keyword that you would use in, let's say, a method header. For example, in Programming Project 5, in the make talks method, you had to indicate that in the method header, you had to indicate that the method make talks could potentially throw an IO exception, because there could be something that goes wrong with the scanner class. Scanner could not be fed a file, for instance. In that case, we have to indicate that, we have to tell the user, hey, this method can potentially throw an IO exception. So I'm going to do that by specifying in my method header throws IO exception, which means throws is more like acknowledgement. It's saying this method could potentially throw this type of exception, whereas throw is the act of actually launching the exception, and that has to do more of like the actual handling of the exception. I hope that answers your question. And then Anna asked, would super be the implicit parameter when you call the parent class methods? Let me think. So super is more of a keyword. I wouldn't really say it's an implicit parameter because it's not really an object, if that makes sense.
I think it's a keyword final, isn't it?
Hold on. I'm looking at it right now. Actually, it says it's used to refer to the parent class object, so I might be wrong.
Oh.
It might actually, that's so interesting. Okay, so let's see. Super, oh, I see. If you did like super dot something. So hold on. I guess there's two ways of using the super keyword. The first is you can use the super keyword by doing like super and then parentheses, which is a call to the parent constructor. And in that case, it wouldn't be an implicit parameter. But you can use the keyword super to call methods from the parent class. So like super dot deposit. And I feel like in that case, it would be an implicit parameter? Hadley and Ileana, do you want to kind of maybe jump in and share your insights?
Yeah, I think from what I am looking at online, like Annie said, there are two different ways of calling it. You can call it by itself, and usually inside the constructor. So my assumption is that it's called in the constructor so that it basically grabs all the, so basically like like invokes the parent class. And then the second way of calling it would be doing super dot and then whatever you're about to use, because you're grabbing it from that super class or like that parent. Yeah, I think that is probably too like more in depth than you have to. Yeah, I'm sure, but I don't know if that's.
Yeah, I think it should be an implicit parameter actually. If you're calling a method like
Yeah.
dependent on super, it would be an implicit parameter that refers to an instance of the parent class. But yeah, that's a good question.
Is ISA refers to the fact that a subclass is an extension of something, like how a checking account is a bank account. Yes, yeah.
Wait, what was the question? Sorry, I disconnected, so I lost all the chat
Yeah.
history.
It's okay. It says, I think IS-A refers to the fact that a subclass is an extension of something, like how checking account.
Yeah, is an instance of the bank account class. That's exactly right. Yeah, so you can think of inheritance. Inheritance is formally defined as the is a relationship between a subclass and a superclass. So that what that means is basically exactly what Ileana was just saying, is that if we do like public checking account extends bank account, a checking account is a bank account, but a bank account is not a checking account. So that's something really important to keep in mind. The parent class is not an instance of the child class, but the child class is an instance of the parent class. It only goes in one way.
Let's see. Kat, was your question answered?
Yeah, thank you.
Oh, okay. Let's see, what other questions? Are there any other questions with this? I know it's like something kind of complicated and sort of we've kind of been using this, but I think this is the first time we're able to say what it's called.
Yeah, I think one more thing to note is, so one kind of like motto that Professor Cannon likes to say is the object reference determines what methods can be invoked, but the actual object determines what methods will be invoked. And what does that mean? Basically, like if I have an instance of checking account, let's say I did checking account C equals new checking account. And then let's say I did, okay, so now that I've created an instance of the checking account class, I know that I have an object reference to, so a checking account is a bank account. So I am allowed to call methods from bank account onto that checking account instance that I just created. However, I cannot call methods of checking account onto objects of type bank account. It's kind of like the thing I was saying earlier with like how inheritance only goes one way. The children are instances of the parent, but the parent is not an instance of the child. So, so like just keep that in mind, because if I have like bank account A equals new bank account, and then I try to call a method of checking account on the banking account object that I just created, then I'm gonna get an error. Java's gonna complain because I cannot call methods of checking account onto banking account. A bank account is not a checking account. Checking account is a bank account. Hope that wasn't too confusing.
Are there any other questions about this?
I know this stuff is like really tough to grasp. So if you guys have any other questions after this review session, you can ask on Piazza or through email, and we're happy to answer answer afterwards as well if anything comes up.
Yeah, so I guess on that note, this is Hadley's last very nicely decorated slide.
Hello.
So just like a couple of words of like encouragement, you guys are almost there. You guys like have this. I know that like your exam is still in a couple more days, so make sure you take these days to study up. Make sure you look at the lectures. And I would also recommend looking at the example files that Professor Cannon has provided. So like Annie mentioned, like bank account is a huge one. Also the CD collection, all those you might see on the final in some sort of way. I would also recommend looking at like your homework assignments and seeing what you did right, what you did wrong, and seeing how like everything works, overlearning the constructor, how you called this like array or array list. Yeah, you guys are almost there. We're here for you all. It's just the final stretch. I don't know do you guys have anything to add? We're here for you all.
Yeah,
Got
that
this.
was great. You guys totally got this. And you've been working hard all semester. So I'm sure you all will pass. Don't stress yourself out and do anything that compromises your academic integrity, because we're all here for you and there are a lot of great resources. We'll post the slides. We'll all be responding to emails and Piazzas, and there's a lot of great study materials available between this and the example code and the terms offered. So I know you guys will do great, and
Yeah.
it'll be really exciting to have it behind you and you can celebrate summer.
Guys, summer is so close. Although the weather here in New York has been super cold lately, I have no idea why. But
Oh my god.
Hadley, was it snowing where you are?
No, I'm in North Carolina and it did not snow. It's actually pretty nice right now, but it was like 60 yesterday, which is a little bit colder, but no, it did not snow.
It's been like pretty chilly for some reason, even though it's May. Like it's insane.
Yeah.
And I'm saying that it snowed in Long Island too.
Yeah.
Oh my gosh. Are there any other final questions? Oh no, Frostwatch.
Wait, what's a Frostwatch?
I mean, like, they were just like, it's probably gonna freeze over.
Oh, wow. Yikes. But yeah, guys, we know it might be like stressful right now, but you're so close. Just make the final push and you'll be free to do whatever you want. So